Hi, welcome to today's on Analytical Geometry, Circles Part 3. Let's have a look at question 5. A circle with center origin passes through the point T35. Determine the equation of the circle. So again, this is the x and y coordinate, and we know if the circle has center origin, it is x squared plus y squared equals r squared. So I substitute that point in. For x it's 3, for y it's 5, and that's equal to r squared. So I'm going to have 9 plus 25 equals r squared, and that's equal to 34. Okay, so therefore the equation of this circle is x squared plus y squared equals 34. Awesome. So now, if the circle is shifted 2 units to the right and then 3 units down, determine the new equation of the circle. So let's get a rough idea of what's happening here. Okay, so it goes through the point 3,5. So here's the circle with center origin, and there's a point here 3,5. Okay, so now if we move this circle, the entire circle, 2 units to the right and 3 units down, it's always good to make reference with the origin, with the center point, what's happening. So if you moved 2 units to the right, okay, and then 3 units down, the new origin would be, let's call it C, and now from 0 you moved to the right 2, so that's positive 2, and you've gone down, so that's negative 3. So that is now the center of this new circle that shifted down. Okay, but remember the circle still had the same radius. Okay, nothing happens to the radius or the size of the circle, it's just the center moved, and every other point on the circle moved. So the radius that we worked out, well, we worked out r squared was 34, and now the new equation of the circle will be a circle that doesn't have a center origin. So it'll be in the form of x minus h squared plus y minus k squared equals r squared. So in this case here, the opposite of positive 2 is negative 2 squared, and the opposite of negative 3 is positive 3. So y plus 3 squared equals r squared, which is 34. So it still had the same radius, that didn't change. Okay, the radius will still be root 34, but the center and every other point here now has shifted as well. It shifted 2 units to the right and 3 units down. So imagine t moved down to t prime. So if I shift 3 2 units to the right, it's going to become 5. And if I shift down 3 units, it'll be 2. So again, not the best accurate drawing for my rough diagram, because 2 is positive, it's supposed to be up here. But anyway, we can check that this point here satisfies this equation. So if I substitute x equals 5, and if I substitute y equals 2 here, what do we get? We get 5 minus 2 is 3 squared, and 2 plus 3 is 5. So we get 3 squared plus 5 squared, which is 9 plus 25, which is 34. And that's what we wanted. So we definitely know that the equation is true, and all points that have been shifted will also satisfy that new equation. Okay, so draw a sketch of the original circle and then the shifted circle on the same system of axes. So again, if I just draw this one here. Okay, so this was that original circle with the center 0, 0, and it had the point T 3, 5. Then we know that there had to be another circle, and it was going to be shifted over and have a center here somewhere. So it'll look something like this. Okay, this is a bit of a rough diagram, but anyway, we know that there was a new point T prime that when shifted down, that was going to be, what was it? Okay, it's not necessarily that point of intersection there. Okay, so it could be somewhere here, for example, T, and we said if it went, what was it, 5, 2. Okay, but the center point is the most important point to label here, and that center point is 2, negative 3. So this is essentially what we're looking for, the general shape of the two circles and the centers of the two circles. Okay, and that is how we would do this type of question. Awesome. I'll see you in the next one.